Part 1. The seemingly impossible problem: proof without disclosure. Imagine you need to prove to a security guard that you are over 21 years old. You pull out your ID. In that moment, the guard now knows your full name, home address, exact birth date, height, weight. You have revealed dozens of secrets just to prove a single fact. This is the fundamental problem of authentication in both the physical and digital worlds. To prove something is true, we believe we must present all the original data. But what if you didn't have to do that? What if there was a kind of cryptographic magic that lets you prove you are over 21 without revealing your age, name, or anything else? This magic is real. It's called zero-knowledge proof, ZKP, and it is the cryptographic heart that makes Interlink's promise of a private digital identity possible. Welcome back to the Deep Dive Technology Analysis series on the Interlink Insider channel. Today, we will decode one of the most powerful, complex, and important technologies in the entire Web3 space. We will explain what it is using simple analogies, look at how it works, and detail exactly how Interlink uses it to build a truly private and secure digital society. Chapter 1. The Classic Analogy: Alibaba's Cave. To understand this seemingly impossible idea, let's use a classic thought experiment: Alibaba's Cave. Imagine this cave. It has two paths, A and B, but they are connected by a magic door at the back. Now, Peggy wants to prove to Victor that she knows the secret password to open the door, but she doesn't want to tell Victor the password. Here's how she does it. Victor waits outside. Peggy enters the cave and chooses one of the two paths, A or B. Victor then goes to the entrance and shouts, "Come out through path B!" For Victor, Peggy might just be lucky. Maybe she happened to pick path B by chance. So, they repeat the experiment. Peggy goes back in. This time, Victor shouts, "Come out through path A!" And again, she does. After dozens of successful trials, the probability that Peggy is just lucky becomes unimaginably small. Victor is convinced that Peggy must know the password. Yet, throughout this process, Peggy never says the secret phrase. She has proven she knows a secret without revealing the secret itself. That is the core principle of a zero-knowledge proof. Part 2. The Cryptographic Motivation: Looking Inside. So how do we turn this magical cave concept into math and code? The answer lies in a few key cryptographic concepts. Chapter 2. ZK-SNARKs versus ZK-STARKs. A quick comparison. You will often hear two acronyms, SNARKs and STARKs. They are the two main families of ZKP. ZK-SNARKs stands for Succinct, Non-Interactive Argument of Knowledge. The keyword here is succinct. These proofs are extremely small in size and verify very quickly, making them perfect for blockchains where data space is precious. Their main trade-off is requiring a trusted setup, a complex initial ceremony to generate system parameters. You have to trust that at least one person in that ceremony was honest. ZK-SNARKs stands for Scalable, Transparent Argument of Knowledge. The keyword here is transparent. They require no trusted setup, making them trustless. However, their proof sizes are significantly larger, which can be less efficient on-chain. For the specific use case of identity verification, Interlink leverages the efficiency of ZK-SNARKs to keep its blockchain lean and user experience fast. Chapter 3. The three pillars of a ZK proof. For any ZKP system to be secure, it must satisfy three mathematical properties. 1. Completeness. If your statement is true, you can always prove it. If Peggy knows the password, she will always pass Victor's test. 2. Soundness. If your statement is false, you cannot cheat the system. If Peggy doesn't know the password, she will eventually be caught. 3. Zero knowledge. The verifier learns nothing other than the fact that the statement is true. Victor is 100% convinced Peggy knows the password, but he learns absolutely nothing about what the password actually is. These three pillars, guaranteed by complex mathematics, allow us to build systems based on verifiable truth without sacrificing privacy. Chapter 4. How Interlink applies ZKP, Real-World Application. All right, enough theory. How does Interlink use this magic to protect you? Case 1. Identity proof. Your verified Interlink ID is like a membership card for the Verified Real People Club, securely stored in your app. When a DApp needs to know if you are a real person, your app doesn't show them the card. Instead, it generates a ZK proof, a small cryptographic receipt. This receipt mathematically proves you own a valid membership card without revealing any details about the card or about you. The DApp sees the valid receipt and lets you in. Simple and private. Case 2. Verifiable credentials and selective disclosure. This is the future. Imagine your identity is not just one card, but a set of facts about you, all cryptographically secured. With Interlink, you can create a ZK proof that only proves you are over 21 to a bar, without showing your name or address. You can create another proof that only proves your nationality to a government service, without revealing your age. This is called selective disclosure. It gives you granular control over your data, allowing you to share only what is truly necessary and nothing more. Part 3. The Impact: A World Powered by Privacy. Chapter 5. ZKP Beyond Interlink: The Scalability Revolution. It's important to understand that ZKP is not just a specialized privacy tool. It is also the key to scaling blockchains like Ethereum. Technologies like ZK rollups bundle thousands of transactions off-chain and then produce a single, compact ZK proof to post on-chain. This proof validates all those transactions without taking up massive block space. The bottom line is, the technology Interlink uses for privacy is the same technology making the rest of Web3 capable of handling global-scale traffic. This is not experimental tech. It is a foundational pillar of the entire future Internet. So, zero-knowledge proofs are not magic. They are a profound cryptographic breakthrough that fundamentally separates truth from data. They let us prove a statement is true without revealing the raw data that makes it true. For Interlink, ZKP is the final and essential piece of the puzzle. AI verifies you are human. Blockchain remembers that. And zero-knowledge proofs are the shield that lets you use that identity in the digital world, safely, privately, and entirely on your terms. It is the technology that ensures a human-centered internet is also a privacy-centered internet. Now that we understand the motivation and the cryptographic shield, who are the active participants in this ecosystem? In the next deep technical analysis article, we will explore the crucial role of the human node and how you, the user, are an indispensable part of Interlink's decentralized security model. You won't want to miss it. Thank you for watching.